Hi, my name is Ravi Sharma, and this is a quick demo on the dynamic modeling of an ocean compressed air energy storage system. And this is part of my MAE 586 independent study project. So at this point, I'm already assuming that you're already somewhat familiar with CAES or OCAES systems. Maybe you've read a couple of papers on CAES or OCAES, and so you kind of know what the systems look like. Here, what I've tried to do is, I've said, okay, well, these are pretty complicated systems, and so if we really want to design something, we need to take a systematic approach, and often that requires some computer modeling. In this case, I wasn't even familiar with this tool before the semester, but after a little bit of research online, I found this tool called Thermolib. And what it is it's an add-in to MATLAB Simulink. It's an independent program which you can purchase a student version of. But what it allows you to do is kind of merge the really nice and powerful system design capability that Simulink has with some pre-built thermodynamic blocks. So for example, on the bottom left here, I have some pre-built, drop-in functions such as a compressor, an isobaric process, or a tank. And so what that allows you to do is focus on designing the system instead of, say, developing your own function for a compressor. There's already a function available, and you can just provide it with a set of inputs, for example, your efficiency or your discharge pressure. Now, my background's in steam turbine engineering and power plants, and so when we're designing a new plant, what we typically do is the first thing we'll do is take a bird's eye view of the system. So you want to know what the major components are that like we have in some of these models, and what the inputs and outputs at various points are. Try to understand how things work together. And after you've done that, then you can jump into more detailed design, say, of individual components like your compressor or your turbine or your storage tank. And then after that, once you get the performance of those individual components, then you can put it back in your model and get a true representation for your power plant. So you can then quantify what the real efficiency and real power output of your system is. So as I mentioned, this is a MATLAB-based tool. And if you've ever used Simulink before, maybe in a controls class, then you should be able to pick this tool up pretty quickly. But once you download the software, there's some nice help functions. For example, there's actually a user manual that comes with the software, and it's very thorough and goes through not just how to model the system, but a lot of the theory in what's built into each of these functions. The other thing that they were pretty good about is there's a set of examples, and there are actually a lot of them. So we have different applications, say even for an entire combined cycle power plant, and those are nice references for you to start building or modifying to develop a CAES or an OCAES system. And then the last thing that I did was I actually just looked up YouTube videos. The company EU Tech that produces this Thermolib software actually has several